All right. So thank you everyone for joining us today for our safety webinar on chain sling inspection. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today will be Henry Brezina. He's corporate trainer at Columbus McKinnon, specializing in rigging and load securement. Henry's a member of the tie-down committee for the WSTDA. This committee writes the standards that are used by the trucking industry, which are also used by enforcement. Henry has been training on crane and rigging products and safety for more than 15 years. It's really a privilege for him to be available to us today to do this training. So before we begin, Henry, can you please go to the next slide? Okay, to the next slide, please. All right, as I said earlier, this session is being recorded. Please look for an email afterwards with a recording link. We post all of our videos on our YouTube channel, and we have a whole collection covering the last 4 years that are available to you. Everyone in attendance today will receive a link, as I said. Everyone is in listen-only mode today, so we encourage you to ask questions in the Q&A pane. We will take 5 to 10 minutes at the end, or really as long as we need to answer all your questions. And the best question that's asked today, and Henry deems, maybe even the top 2 questions, we would like to turn into a blog post as a follow-up to the webinar. And the 2 questions we ask, the people that ask them will get some promo items from Columbus McKinnon as a thanks for your engagement. So we appreciate your attention, and now I'd like to turn the meeting over to Henry so that we can begin. Henry?
Hi. Thank you, Gisela, and thank you all for tuning in. I'm glad to see there's quite a few folks that are obviously interested in this material, which is phenomenal, and it is awesome too. All right, but first thing I'd like to say is, this is not a training session. It is intended for general purposes, general information only. If you do have any questions, you should consider looking this information up either in the standards, OSHA, or whatever applicable industry application that would pertain to this information. All right, so first thing what we're going to do is we're going to cover today in the next hour or so is going to be definition of terms. We'll talk about what is meant by specific words, because a lot of the standards and a lot of things that OSHA print are very, very word specific. Understanding the differences between ASME and OSHA, and in some cases there is a difference. Some cases they're very, very parallel to each other. All right, identifying your rigging gear. Basically, what's the difference between a good piece of rigging gear versus a bad piece of rigging gear? Understanding which OSHA regulations or ASME standards apply to the rigging gear that you're about to use. All right, it pretty much is self-explanatory. OSHA does cover a lot of things. ASME covers a lot of things, and between the two, they pretty much do a good job. All right, and then of course, general inspection and testing requirements as per the standards as well as OSHA. All right, so first we'll get into the terms. One of the things that some people get kind of confused about is a qualified person. That's a person who, like it says, is by a possession of a recognized degree or certificate of professional standing, or who has a lot of experience or knowledge. All right, that's going to be probably your 20-year person, 25-year person, even your 10-year person. All right, they've got a lot of information in their head. That person's going to be qualified to do a lot of different things, especially when it comes to rigging. They're probably going to be able to look at a piece of rigging gear, a shackle, for example, and look at it and say, you know what, that's the right size, use that one, or you know what, that's the wrong size, or it's got a nick in it, don't use it, it's no good. That's the person. That's going to be our qualified individual. A designated person is a person who's selected by the employer. The employer chooses this person simply because the employer knows what that person's background is. They know their history. Maybe they've been with the company for a half a dozen years or so. Their experience is well known to the company. They know what their resume has read. They know what their education is. So that person's going to be for example, your designated engineer, electrical engineer, your electrician, your plumber. People like that, they have very specific skills. All right, a competent person is to be one who's capable of identifying existing and predictable hazards. This is going to be probably more likely a supervisor, an engineer, or somebody who has a vast amount of experience in that field, they can actually kind of look at it and they'll be able to tell that, you know what, you can't do that job that way, because if you do, this is what's going to happen. I've seen it before. Those are the people that you want around as well. That's going to be your competent person. A sling manufacturer is a person or a company who basically assembles the sling. All right, it could be anyone. All right, it doesn't have to be Columbus McKinnon. All right, it could be anybody out there can put together a sling. Point is you need to know who the sling manufacturer is, simply because they're the ones that are going to basically put their name on that tag to identify themselves as the manufacturer. All right, so let's talk about what the difference is between ASME and OSHA. OSHA came in the early 70s. Obviously, from the slide, you can see that workplace fatalities had dropped by 60%. Injuries had dropped by 40% just in that year alone. All right, that's pretty significant. All right, they also have a Code of Federal Regulations. In this case, it's Code of Federal Regulation number 29. OSHA has governs slings under 1910-184. All right, that is a publication by the federal government. All right, when you read something that is published in OSHA, that's law. You have no choice but to comply with it. All right, it is what it is, and that is the law of the land. All right, they do have what they call the general duty clause. All right, OSHA has a lot of things listed in the regulations. Unfortunately, they don't cover everything 100%. There are times where you might look in the OSHA regulations and actually find out they don't say anything about this particular product or how this product gets used. That's simply because what they're doing is they're going to rely on the industry standards for that product or that process. And that's where the general duty clause comes in. And what the general duty clause actually says is what I have here up on the screen. It's that the employer shall furnish to each of his employees employment and a place of employment which are free of recognized hazards that are causing or likely to cause death or serious harm. All right. They also have to comply with all of the federal regulations pursuant to this act. All right. There also is a part on here for the employees, and that is the employees shall comply with all of OSHA rules, regulations, and orders issued pursuant to this act as well. What that basically means is just because OSHA doesn't cover it, if it's written in an ASME standard, they can fall back on that through the general duty clause, and that will hold up in a court of law. So just because your facility someone in your facility may say we are 100% OSHA compliant, that's only part of the equation. You have to not only be OSHA compliant, but you'll also have to understand what standards cover what you're actually doing in your facility or using components in your facility or doing some actions that technically aren't covered under OSHA, but they are covered under some standard, in this case, hopefully ASME. All right, OSHA regulations are law. Like I said before, they are the law of the land. You have no choice but to abide by them. All right, and that's why people, I shouldn't say people, but companies, and including people, will get citations written by OSHA because they violated something that OSHA had written down, and that is law. It's a speeding ticket. You get caught out on a highway, the officer pulls you over, they're going to give you a speeding ticket. Hey, I got a speeding ticket. What am I going to do about it? You pay the fine, okay, and hopefully you correct the situation. ASME are rules created by industry leaders. In a court of law, they can be used as binding just like OSHA through the general duty clause. All right, again, OSHA doesn't have everything written down 100%. They rely on the industry standards people, in this case ASME, and they will draw on what ASME has already in place. They will also draw on what the manufacturers of that particular item have in place as well. So it is important that you understand not only what the industry standards are, but also what the manufacturer requires of the person using this particular piece of equipment and how it gets maintained. All right, documents do change considerably throughout the years, as well as OSHA, as well as ASME. All right, So it is prudent for you to follow and make sure that you stay up on those changes. On average, the ASME standards get updated every 3 to 5 years. All right, they're usually on that kind of a cycle. All right, so if you've got a set of standards that are, say, 10 years old, you probably should go to ASME's website and look to see if that standard's been updated. If it has, I would consider purchasing a new copy of that standard. All right, when OSHA and ASME do vary, you should follow whichever one is more stringent. All right, because again, even if OSHA doesn't have anything to say about it, doesn't give you a free pass, if ASME does cover it, OSHA will cite you based on the ASME standard, again, through the general duty clause. The vast majority of citations that OSHA does write are based on general duty clause, all right, which basically means they don't have anything specifically in their regulations that cover it. All right, here's a typical lift that happens thousands of times a day throughout the country. This individual, he's picking up a steel plate off of a table, and you can see he's got a jib boom hanging there. He's got a hoist hanging off the jib. He's got some slings coming off the hook of the hoist going to a spreader. The spreader has a couple of slings coming off of that, and then he's got a couple of plate clamps on the bottom. All right, you can see there's 1, 2, 3, 4, 5, 6. Looks like 6 different standards that are covered in this one lift, as well as OSHA 1910 and 184, which covers the chain slings that he's using. And you can see from all of this, there's actually only one item on here that OSHA actually covers. All the rest are covered under ASME B30 standards. So does this individual have to know all of these standards inside and out while, in order to do his job? He should be aware of them and how they function, and that will come into play when he's trained to do this job. So training is very, very important when it comes to rigging and lifting products. Because, some people say, well, I'm only lifting 100 pounds. It's like, well, I got news for you. 100 pounds can hurt you just as much as 100,000 pounds. It's just not something that you want to play around with. You want to make sure that the person is properly trained to lift the proper loads is the proper way. All right. There are different. Yes.
I just have a quick question. How often are these standards updated?
About every 3 to 5 years. There's the rotation. They tried. I know I've spoken to many people on the ASME committees. The maximum they want to go is 5 years. The minimum they try and do them in 3. I know they've been the last few years. They've really been pushing to get all of them updated. And I think that's B30.9 just got updated and I believe is in print now.
Okay. All right. Thank you.
Okay. All right. The different types of rigging gear that are out there that are covered under ASME B30.9 are the various slings that are out there. There's chain, wire rope, metal mesh, synthetics. B30.10 covers hooks. And in this, if you were to look at B30.9 and start reading about what it says about a different type of sling, it will tell you everything you want to know about that sling, how it's to be used, how it's to be maintained, how it gets repaired, things like that. But when it gets to the end of the sling where the hook is, it will tell you for that information, go to ASME B30.10. So the standards do kind of play on each other. So that is something that you're going to have to be aware of as well. All right, overview and inspection of chain slings. Basically, the anatomy of a chain sling is up at the top. Obviously, we have a master link. Is that the only thing that can be there? No, it can be a number of different things. But in this particular example, we do have a master link. We've got some couplers that hold the chain, the body of the chain itself, to the master link. At that coupler, we'll have an ID tag. We'll have couplers at the other end of it that attach it to a some kind of a hook or an attachment at the end of that sling. And in this case, this happens to be a Herc Alloy 1000 chain sling. All right. So when we're looking at our sling and we're going to be doing an inspection, we're going to start up at the top. So we're looking at our master link. All right. We're also looking at our ID tag. when I do my rigging classes, this is the first thing I tell everybody that comes through my classes is the first place you want to start your inspection is at that ID tag. Look at that ID tag and read the information. If you can read the information, write it down, because then that's going to tell you what that sling is. And the information that's on that tag must match what the sling is made of. All right, so if you cannot read the information on the tag, guess what? The inspection is over. That sling just failed. All right, so the tag has to be there. It has to be legible. All right, the information that you're going to find in the sling as well as on the tag, the master link, how big it is, the manufacturer's mark has to be there. That has to be identified. All this information has to be legible. The chain itself, you can mic it up to find out what size it is. Say, for example, it's 3/8. What grade it is, you'll find that out from the chain itself. The chain will have identifying marks on it. On Columbus McKinnon chain, we put the grade of chain, grade 80, grade 100. We'll also have the CM logo on there. There will also be at least a 3-letter trace code on there. For folks out in the field using that sling, those letters mean nothing to you, but to us, it's an internal serial number. We can identify who, when, where, what time, what machine, what operator actually made that chain. So if there's an investigation into a particular piece of chain, we can readily find that information out. Again, the ID tag has to be there. It has to be correctly labeled and legible. All right, the hook itself also has to be marked. The grade, the manufacturer, some kind of an ID on there. Usually you'll see a little logo. I haven't come across any hooks where the entire manufacturer's name is on there. It's usually a logo of some kind. And of course, if it has a latch, the latch has to be there. It has to function. All right, so if it is equipped with a latch, it has to function properly. The other thing that's very important, a lot of people kind of miss the boat on, is the reach. The reach is bearing point to bearing point, and that's true with every sling, whether it's chain sling, wire rope, or synthetics. When you want a 10-foot long sling, that's the dimension that you're looking at. That is your reach. Some people seem to think that's how much, in this case, how much chain is in between the master link and the hook, and that's not the case. So just be aware of that. All right. Also, some of the things that you'll see on the tag are the different types of chains. In other words, what kind of a sling do I have? All right. In this case, you'll see the letters over here, and you can see this table has a bunch of letters on it, and those letters do mean something. First sling you'll see is an SOS. You'll see a DOS, a TOS, and a QOS. Well, obviously the SOS, it's a single leg sling. It's got a master link at the top, and it's got a sling hook at the bottom. And that's exactly what those letters stand for. Is the first letter means it's a single sling. It's got one leg. You can see on the DOS, it's got two. It's got a double. T is triple. Q is for quad. The O will tell you what one of those end connections are. In this case, the upper connection is an oblong master link. So we put an O in there. The bottom connection is going to be our last letter. That tells us it's an S. It's a sling hook. It could be a G for a grab hook. It could be an F for a foundry hook. It could be a number of different types of things. But that's how they identify the different types of slings. And that's pretty much throughout the industry when it comes to chain slings. All right. This one here, also there's some chain slings will have adjusters on them. In this case, you can see on this one is a single leg adjuster. All right, we've got a double leg adjuster, and then of course we've got our double basket loop. All right, it's just a double basket. I'm sorry, it's not an adjustable. So those are the three more additional different types of slings. But again, the coding will tell you what kind of sling it is. All right. And also, when it comes to the numbers, like I said, all chains are identified. The number equates to the strength level of the chain. So the beginning is you're looking at grade 30. That's the kind of chain. We call it proof coil chain. It's basically tested at least 100% of its working load limit. It is not heat treated. It is, when it's welded, it's trimmed, it's cleaned up, and it's put into a box or a barrel, and it goes on a shelf. All right, that's it. When you go to the hardware store and you're looking at Home Depot or Lowe's or Menards or whatever hardware stores in your neighborhood, and you see the vast majority of chains that they have on the shelf there are going to be grade 30. Do not use those for overhead lifts. There's grade 43, grade 70, grade 63, grade 80, grade 100, grade 80, grade 100, grade 63. Those are the ones that we want to use for overhead lifting. They do have alloy components in them, and that's why we can use them for lifting purposes. Grade 43 is called high test chain. Do not use that for overhead lifting. It is a little bit higher working load limit than grade 30, but again, it does not have any alloy properties, so it does not stretch very much before it breaks. Grade 70, it is a hardened piece of chain. Again, it does not have alloy properties in it, so it cannot be used for overhead lifts. So make sure that when you do select a piece of chain, look at it. The chain will tell you what kind of chain it is. All right, anything over 5/16 will be marked. Smaller ones than that, you got to look at the tag, and the tag has to be marked properly. All right. So, like I said, grade 63, 80, 100 are called alloy steel chains. They are used for overhead lifts. They contain alloy elements in them that allow them to basically stretch or elongate a considerable amount, and that amount is at least 20%. All right. There's the reason why we want the chain to stretch is it gives the operator, the rigger, an indication that something is wrong before you have a catastrophic failure. All right. And all the manufacturers that make alloy chain for lifting purposes have to have this ability. They got to be able to stretch 20%. The thing is once the chain stretches, even if it only stretches 1% or 0.5%, you have to take it out of service. All right, no stretch is allowed. All right, but it's there as a warning for the operator and the rigger. All right, 30, 43, and 70, again, like I said, they're carbon chains. They're not to be used for overhead picks. So here we got 3 different chains. Grade 63, which was introduced in 1935 by Columbus McKinnon. Grade 800 or grade 80, people call it as well. It was also introduced by CM in 1972, and grade 1000 or grade 100 was introduced in the year 2000, again by Columbus McKinnon. All right, like I said, you're going to see all these markings. You'll see the grade, you'll see the company logo, the CM USA logo on there. You'll also see a 3-letter trace code. So that information has to be on the chain. All right. Chain can be used at elevated temperatures. Obviously, if I'm picking up a load that's at least hot to the touch, maybe a couple hundred degrees, I'm obviously not going to use a synthetic sling because they run the risk of melting it or even burning it, maybe even setting it on fire. All right, so we're not going to use a synthetic for hot loads, but we will use chain for hot loads. Chain is a little bit more applicable for hot loads. Unfortunately, it can't take very, very hot loads, all right, because obviously it's made of steel. If we pick up something that's way, way too hot, something in excess of 1,000 degrees, we have to take that chain out of service. Simple reason is we're starting to change the molecular structure inside the chain. We heat chain up, we quench it in the fluid to give it a hardness. Depending on what the temperature is when we immerse it, we know what fluid it's going into, we know what the hardness is going to be. We know what that chain is capable of sustaining as far as load goes. And that's all the companies do that. So when you make this chain susceptible to higher temperatures, you may lose working load limit at the time of lift due to the higher or the elevated temperatures. But once it cools off, you're back to normal again. Conversely, is if you pick it up at some really elevated temperatures, you're going to have some working load limit loss at the time of the lift, and it may sustain itself within the chain after the lift is done. In other words, when the chain cools down, you may have lost some permanent working load limit. So this chart here will tell you what those changes are. All right, but the big thing here is you have to know what the temperature is of the item that you're lifting. You can't guess. You physically have to know what it is. Mechanical coupling links. We do manufacture mechanical coupling links. We call them hammer locks. They are used to join the end of the chain to a attachment, master link, a hook. It is not to be used to join two pieces of chain together. Even if you're making an endless sling where you take a piece of chain, put a hammer lock at one end, and then put the same hammer lock to the other end. That is not allowed. That is actually strictly mentioned in ASME B30.9 not to do. All right. So hammer locks, like I said, are mechanical couplers. They are proof tested by the manufacturers. All right. They can be used for overhead lifting. They are not repair links. I can't stress that enough because people do use them as repair links. They are not repair links. They tend to be bigger than the original chain link itself. So if you've got, example is you got a 3/8 chain link that you want to replace because it's damaged, and somebody puts a hammer lock in there, that hammer lock is going to be much larger than the original chain link itself, which means now your sling has grown in length. Not only that, but if you're passing that sling through something, the hammer lock is likely to get caught. Plus, the hammer lock articulates in a different way. So there's several things that are happening there. We don't want people to use these as repair links. I can't stress that enough. So please do not use these for repair links, even though the temptation is there.
Oh, that's an excellent point, Henry. Quick question, Henry. I would like to launch a polling question.
Sure.
Everybody can look. Just to throw this out there, what year did CM introduce the 1000 series chain or series 100? Was it 1980, 1990, 2000, or 2010? If you're on an iPad, you won't be able to vote. You can give me your answer in the Q&A thing. Otherwise, you can select it. So what year did we introduce this graded chain? 1980, 1990, 2000, or 2010? Looks like, Henry, about 65% think 2000, about 20% think 1990, and the rest is divided between the other 2 years. You can go ahead.
I was going to say, this one should have been easy. It should have been 2000. Got grade 1000 introduced in 2000. So should have been an easy one.
Okay. Anyway, you can confirm. Thank you.
All right. Thank you. All right. There are other connectors out there. Like I said, these are all low carbon connectors. These are readily available in just about any farm and tractor supply store as well as hardware store. And that might be one of the reasons why a lot of people use them, is because they have easy access to them. And they use them for repair links or connections between a chain and a hook. And unfortunately, these are not connectors that you want to use for that purpose. These are very low carbon connectors. They're not to be used for overhead lifts. All right. This chart here will tell you what the embossing is, right? If you look at the left-hand column, you'll see all of the various companies that manufacture chain. All right. And I believe these are pretty much worldwide. I don't see any on here that I don't think we missed any, but anyway, the one thing I want to really point out to you is, like, say for grade 80, if you look at how all of the different companies mark their grade 80 chain, you'll notice they use the number 8 in one way or another. It's either grade 8 chain, grade 80, grade 800, but they're all using that number 8 in one fashion or another. They're doing the same thing with grade 100. They're either using 10, 100, or 1000. All right, they're all doing that. So after today, I mean, it doesn't really matter what kind of chain you're using or whose chain you're using. You should be able to look at it and see what kind of grade it is, and then go from that point. So if you've got the tag will tell you what grade of chain it is, and then you can verify it with the chain itself. All right. The tags, there are a number of different types of tags. What's got to be on the tags, the rated load at the angle that the chain can be used at or the sling can be used at, the reach, the size of the sling itself, in other words, the size of the chain, the grade of chain, whether it's grade 800 or if it's grade 1000, the manufacturer's name or their logo has to be on there, what type or the type of sling it is. It could be a dual leg, single leg, triple, quad, or an endless or an adjustable. The serial number. All chain slings have to be serialized. No doubt about that. All right. The tag is the identifier. Okay. It tells you what you have. Again, when you're doing your sling inspection, this is the first thing that you want to look at. You can't read it. Got news for you. This inspection's over. All right. Compare it with the manufacturer's chart. All right, if you look at the tag, and in this case, we'll go with 1/2 inch. If it's a 1/2 inch chain and it's rated for 60 degrees and it's a dual leg, in other words, 2 legs, or you're looking at 60 degrees, it's good for 20,800 pounds. All right, that number should be what's stamped on the tag as well. All right, so verify it. All right, the tag, these are some of the tags that we manufacture. You'll see you got the CM logo on there, so we know it's a CM tag at least. Hopefully it's a CM chain as well. All right, in this case, it's got the Herc alloy, so we're calling it grade 800 or grade 80. All right, it's got a serial number that'll be stamped on it. It's 3/8 by 10 foot, which means I have 3/8 chain, and it's got 10 foot of reach. All right, it has 2 branches, so it's a dual leg. It's 60 degrees from the horizontal, so basically from tabletop upwards, it can go 60 degrees, which is good for 12,300 pounds. That information has to be on it. Like I said, compare it with the tag, with the manufacturer. Really, really important is now, because we're basically dealing with 2 types of alloy chain, grade 80 and grade 100, make sure you have the right chart. Because again, if we look at 1/2 inch chain for grade 100, because this chart is grade 100, and we look at dual leg or 2 legs, at 60 degrees, you can see this one's good for 26,000 pounds, where the other one was only 20,000 pounds. So make sure you have the right chart in front of you. All right, links, master links, attachments up at the top. Basically, again, manufacturer's mark has to be on there, the size has to be on there, or the rated capacity, and then grade. All right, all that information has to be able to be on there. All right, we got to be able to identify what kind of equipment we have. It's important to inspect chain slings regularly and keep a record. All right, before inspecting it, make sure you clean it. All right, you want to make sure you clean it in something that's not corrosive. It's not going to cause the chain or any of the components to rust or basically dissolve. I mean, some acids out there are pretty powerful. What we're looking for twists and bends, nicks and gouges, excessive wear at the bearing points, stretch or elongation, all right, distortion or damaged master links, couplers. We want to make sure that everything out there has the identifying marks. If you find something bad, mark it plainly, all right? Get some yellow paint, white paint, red paint, whatever, mark it, okay? And then it can be removed from service, okay? So in order to complete a thorough periodic inspection, a chain sling should be free from foreign material. All right, you got to clean it. Slings that are used in a paint booth get paint on them all the time. Unfortunately, that paint has to come off in order for the inspection to take place. All right, so complete inspection or damage of the sling shall be periodically performed by a designated person. So that's what that person's job is. All right, each link and component shall be examined individually. So yes, if it's a very, very long chain, he's got to look at every single link, all right, because we're looking for interlink wear, we're looking for damage, nicks, gouges, anything like that. All right, again, you want to clean it with something that's not acidic, it's not caustic. All right, when you do a periodic inspection, you do have to record this. All right, so you'll need to make some kind of a list of things that you're looking for and record this information.
Henry,
right?
Henry, I just have a quick question that came in a little earlier, but it applies exactly to what you were just covering. So if in the manufacturing process the marking is covered with paint or powder coat on the tag, would the sling be rejected? I mean, let's
If you
say, I'm sorry, not from the manufacturer, but if somehow paint gets on the tag, would it be rejected?
Well, the paint itself isn't cause for removal. It's the fact that the paint can conceal things. If it's just on the tag, as long as you can read the tag is not lifting anything. It's not going to bear any load. So if you can still read the tag and the tag is painted, that's still okay, as long as you can read the tag. But where you run into problems if the sling itself gets painted, or someone paints the sling purposely because they're like, oh, it's got a couple of little scratches. Once I paint it, it'll hide the scratches. Unfortunately, that's what some people will do.
Okay,
All right, that's where the paint's got to come off. That's why we say you got to clean the sling in order to look at it.
great. Thank you.
Okay. All right, so inspections of your chain slings need to be done daily or pre-use. If you're using the sling, say for all day long, and there's 3 shifts using the same sling, that sling should be looked at least 3 times. All right, so records need to be kept for slings for the periodic inspections for at least a year anyway. Additional information may need to be kept as well. And that's basically for warranty purposes. If you keep your records clean and you have an issue with a sling somewhere down the road and you call the manufacturer and say, hey, I have a problem here, that's one of the things they're going to ask you. Let's see your records. All right, so you need to keep those records. All right, reasons, you want to gain knowledge. How are we using the sling? If the sling is constantly coming in, if that one sling is constantly coming in with the same defects or damage done to it, well, is somebody using the sling improperly, or are we, maybe we shouldn't be using this sling in this application. Maybe we've got the wrong tool for the job. All right, the severity of the conditions that the sling is subjected to. Again, do we got the right sling for the job? All right, the nature of lifts, is the operator using it properly? All right, maybe the guy's taking it and he's wrapping it up and putting it in a knot and then somehow getting that knot out at the end of the day, but at the end of the day, it's damaged. So it's like, what's going on? Well, these are the things that you wanna find out in your records. The records will bring this out. All right, what you want to do is you want to keep the most recent record. If you're doing periodic inspections and they're like on a yearly basis, well, then because of the frequency of the use, then yes, you want to keep at least a year's worth of records. You also have to have a copy or an electronic copy or a hard copy of your test certificates, right? And those are available from the manufacturer. This is all information that you can get. Nobody's trying to hide any of that information from any of the customers. ID tags, they have to be there. What's got to be on them is the size, grade, the rated capacity, the reach, who built the sling, the manufacturer, and of course our serial number. All right, thorough periodic inspection of slings has to be done by a competent individual. All right, what are they looking for? They're looking for wear, deformation, increase in length via stretch or wear, sharp traverse, nicks and gouges, abrasion. And abrasion could be, somebody might have nicked it with a grinder, somebody might be dragging it along the floor, concrete floor, and it just starts to wear away at the sling. Corrosion, when you start seeing pieces of rust coming off of a metal object, in this case a chain sling, yeah, the corrosion's bad. All right, heat damage, weld spatter, burns. Welders will use chain slings to hold loads up, and until they get their 2 pieces welded together, unfortunately spatter can end up on the chain sling. Once that happens, you have to take it out of service. All right, we also want to look at the attachments, the hooks, the rings, the oblong master link, any kind of attachments, and those will all be in there for wear as well. All right, these are just some pictures of items, some of the items that we're looking for: bends, twists, stretching, interlink wear, heat damage, nicks and gouges, knots, homemade hardware. These are things that you do not want to see out there. All right, adjustments. You can see here how they took a couple of bolts and just twisted a couple of links to the side because the sling had stretched, and that one side of the sling got a little bit longer than the other. They needed to back it off. So again, these things are not things that you want to see out there for the lifting world.
Henry, I have another quick polling slide I want to do on that topic. So,
okay.
What is the minimal elongation requirement for a chain to be used for overhead lifting for ASME B30.9? Is it 5%, 15%, 20%, or 25%? Let's see how many know this. I know you covered it earlier. Let's see. So again, what is the minimal elongation requirement for chain to be used for overhead lifting for ASME B30.9? 5, 15, 20, or 25%? Again, Henry, it looks like 60% think 20% elongation, and the other balance of people think 5%. So can you share the answer, please?
It would be 20% for ASME. All right, but like I said there earlier, no stretches is allowable. It's just 20% is there to show that something is happening with the sling. All right, so at that point, it would need to be taken out of service. But any minimal amount of stretch, even a 0.5%, once that chain has stretched, it's gone past its elastic limit, it's not going to go back. It needs to come out of service. All right, so continuing with sling inspections, obviously corrosion, that's pretty bad. It is, but you know what? You'd be surprised at how many people would continue to use a sling like that. All right, deformation, you can see here how somebody kind of looks like somebody might have nicked it with a grinder. Heat damage, weld damage, these are all examples of slings that need to come out of service. All right, when we do check slings, chain slings for wear, and they will wear, it's only a matter of time that will happen because you got steel and steel contact. Each one of those links is bearing on the other. That's where we need to check for wear. And that's what this slide is showing you, that T dimension. That's where we want to check for wear. It's very rare that the chain will wear out on the outside, you know, where the straight legs are of the link. It's more where it's going to wear where they start to meet each other. All right, so that's where you're going to want to take and put a caliper in there, or if you have a chain gauge, you're going to want to check for wear there. All right. When you get to some of the attachments, we've got master links, we've got oblong master links, we've got round rings, we've got pear-shaped links. Again, missing illegible information, they need to come out of service. Heat damage, unauthorized modifications, welds. Master links are a good example for some modifications that get done, especially the ones that are fairly large, where you actually need two or maybe even a crane, two people or even a crane to pick it up. They'll weld handles on the outside edges of the master link so two people can pick them up. And unfortunately, that can be done here at the factory because then the link will get heat treated after everything's all welded. Once you do that out in the field, once the unit has already been through welding, then yeah, that's a problem. All right, corrosion, excessive pitting, 10% wear. 10% is a number that you're going to want to keep in the back of your mind. 10% is you're going to find that throughout a lot of the standards. 10% wear is what the human eye can see. So if you can see wear or feel it, chances are you may be at or near that 10% mark. I would check it with something that's a little more precise rather than your eye and get in there, because your eye is telling you something's wrong. What a caliper or a micrometer will tell you if it is indeed bad. All right, bends, cracks, twists, all those items that would need to come out. Nicks and gouges, like the bottom one says, anything that causes doubt, take it out of service. All right, you got to remember, you're picking things up. You don't want this thing come crashing down to the floor. All right, so here we've got a number of things that are bad. We got some heat damage. We've got an elongated master link. It basically got stretched. And we've got some really, really excessive wear going on in these other two pictures, as well as a couple of nicks and gouges in there. All right. Hooks. Hooks are some things that people tend to kind of miss a little bit. What we're looking for on our hooks are deformation, bends or twists. What I tell my classes is if you take that hook and turn it sideways so that I'm looking at it straight on, I should see a nice straight line. If I look at it and I can see that that hook, the tip of the hook might be bent over a little bit, or even the eye might be bent over a little bit, that hook needs to come out of service. All right, the throat opening, any distortion that causes an increase in the throat opening of 5% not to exceed 1/4 of an inch, that, or whatever the manufacturer recommends. All right, the manufacturer can trump that number, that 5%. Some manufacturers will allow you to go out 10%. All right, but again, that's a manufacturer's call. And so again, I'll go back to what I started earlier. You need to not only know what the ASME standards are, and that's what ASME standard is the 5% not to exceed 1/4 of an inch, but also what the manufacturer says. So if the manufacturer allows you to go more than that 5%, then that's okay, but that manufacturer has to have that in writing. All right, you can't just automatically assume a CM hook, it goes by the ASME standards, it's 5%. A Crosby hook, maybe Crosby will say, you know, well, our hook will go out to 10%. Make sure you find that. Okay, so it's very, very important that you find that information. All right, inoperative latches, if the hook comes with a latch, the latch has to be operable, and it's got to be the correct latch. Where, again, like I said, here's that 10% number again, or whatever the manufacturer says. All right, again, like I said, the manufacturer may allow more wear. All right, but again, you don't know that until you ask or you get the information. Markings, manufacturer's logo, that all has to be there. You know, that information, you want that information on rigging gear, whether it's a hook, chain, master link, plate hook, whatever. You need that information there because you're picking things up. They all have to be marked. All right, latches on slings in the standards as well as OSHA does not state that a latch is required. All right, it must be repaired only if it's damaged. All right, unfortunately, some people seem to think that all sling hooks must have latches. That is not 100% true. All right, if you've got a single leg sling and it's got a rigging hook on the end of it and it does not have a latch, you're fine. You can still use that hook in that sling. It's not a problem. If you have a dual leg sling or a triple and one of those latches, and all three of them or all four of them have latches and one of them maybe is missing or maybe damaged, you've got to get those other ones either replaced or repaired. All right, it's an all or nothing type thing. All right, the thing is, what CM recommends is if we have provisions for a latch on our hook, we recommend that you put a latch on it. All right, so that's kind of important. Reason why is if OSHA comes in and sees a CM hook, they know that we recommend that you put a latch on there. You should put a latch on there, unless there's a reason why you can't have a latch. All right.
All right, Henry, thank you so much. Covered a ton of ground, and we have about 10 questions. I know we've kind of maxed out on time for what we said we would do. So if you are interested, we will go through all these questions. Some of them kind of overlap each other or build on each other, so we should go through them pretty quickly. But first off, if a low tag is missing, how do you come up with a reach to measure?
Well, you can physically measure the bearing point to bearing point with basically a tape measure. All right, but the inspection should have been over at that point, prior to that point, because if there is no tag, then how do you know that the chain is the right reach? You don't even know what the working load limit is of the chain, or of the sling, I should say. All right, so at that point in time, the reach is irrelevant. The tag's missing. It needs to come out of service.
Okay. And we talked earlier at the very beginning about how a recent standard was updated. The question was it the 1910.179? Which was the recent standard that was just updated, or the standard that was recently updated, Henry, that you spoke
That
to?
would have been ASME B30.9.
B30.9. Okay, thank you. All right. Can we purchase a new tag if it's lost? If yes, do we need to load test to qualify the sling?
I'm sorry, repeat that?
Can we purchase a new tag if it is lost? And if yes, do we need to load test to qualify the sling, or to make sure the sling is qualified? Or
If all you're doing is, if you're doing an inspection and you're replacing the tag, that's fine. A load test is not required at an inspection or a periodic inspection. A lot of people seem to think that a load test is required yearly. That is not the case. The only time a load test is required is if you repair, replace, or alter load-bearing components. So if you repaired the chain or put a different hook on it, yes, it needs a load test. But if all you're doing is you're doing your annual inspection, your periodic inspection, and say the tag is legible, but maybe it's kind of getting bent and you want to replace it, that's fine. You do not have to do a load test to qualify that sling.
okay, and I think you just covered the, I think you just covered this point, but just in case. When does a chain sling hook not require a latch kit?
It per standard, per ASME B30.9 as well as OSHA 1910-184, a sling hook does not have to have a latch. In other words, it's not there in writing for everyone to do. You don't have to have a latch. But if it's a CM sling hook and it has provisions for a latch, we recommend that you put a latch on it. And OSHA will hold you to that via the general duty clause.
Okay. Okay, as chain links are formed, is there a tolerance for the individual link size? Specifically, if a multi-leg assembly is made and the legs are cut from the same drum, will they match exactly?
Yes, they will. As a matter of fact, our folks in our plants, when they're taught to make slings, especially multi-leg slings, they're taught to take the chain from the same barrel. If they take the chain from another barrel to make one of the legs that they've already made from the chain out of a second barrel, yeah, there's a chance they may mismatch. But yes, you are correct. There is a tolerancing on the chain, and that tolerancing, from machine to machine will vary. It will vary. So that's the reason why people are taught to take the chain from the same barrel.
Okay. Am I required to have more than 60-degree rating on the link?
What do you mean 60? I'm kind of lost because the ratings, normally you're going to see ratings either 60, 45, or 30. You won't see anything lower than 30. And if you're going above 60, well, then you're actually gaining working load limit.
Okay.
So if you're at, like, say 70 degrees, if your rating at 60 degrees was, say, 10,000 pounds, then at 70 degrees you're actually a little bit higher than 10,000 pounds. So you've basically given yourself a cushion of safety there.
Okay. Do I need all three, or can I use only 60?
You only want to use one.
Okay.
You only want to use one.
Only one. Okay, perfect.
Yeah.
All right, just a few more questions. So let's see, we talked about that one. If I purchase let's see, just to be clear, if I purchase a CM oblong link and the orange powder coat has backfilled the stamped ratings from the mill, I have to strip the orange paint coating. Is that correct?
You should be able to read them. I mean, you'll be able to read the markings. I don't know of any of our coatings that are that thick where we can't read the markings. Not only that, but once you use the sling a few times, I guarantee you that paint's going to come off. Slings get beat up pretty good. That paint doesn't stand a very, very long life. It will come off.
Okay. Yes, and another person commented, some slings are painted, coated from a manufacturer. What are we looking for? How do we inspect? This person is talking about PWAG chains, for example.
Yeah, I mean, if there's a question as to whether or not they can read the markings on it, yeah, take the paint off. You know, obviously you want to take it off, but you want to take it off in such a way that you don't damage the link itself.
Okay. You said earlier a sling should be removed if it is stretched, but after that you said 10% of wear is permissible. Does this mean that a stretch of 5 to 10% should be okay? Because
Stretch and wear are two different things.
Okay.
Stretch, you're actually pulling the metal apart. Wear is you're actually, what it says, you're wearing the metal away. And wear is different. Stretch is basically if you take a rubber band and you take that rubber band and stretch it a few times, what ends up happening is the rubber band breaks. You've gone past its elastic limit. And that's what stretch is in a chain link. That's why stretch is visible, because whenever you pick something up, there is some movement in the metal, but there isn't enough movement to keep the metal at that point. It actually comes back. All right. I mean, it's hard to kind of conceive of it that way, but that's exactly what it does. Where metal and metal comes in contact, we're actually basically almost filing it away at just on a microscopic level. And that's what I'm talking about wear. That's where wear will come in.
Okay. All right. I've been told a mechanical sling put together with all items having been tested in manufacturing that a pull test is not required. Is that true? Because all
Yes.
the chain has to be tested prior to shipping.
Yes, those items have all been tested. Every link of chain that comes out of our factory is load tested. The hammer locks, the master links, the hooks, everything gets tested before it leaves the plants. So that's the advantage that you have with mechanical couplers, is you can put a sling together with mechanical couplers and you don't have to load test it because all of that's already been done for you.
Okay, and we have a comment from Troy Raines, who's Troy Raines. He is our rigging engineering manager. Many OSHA inspectors say if there is a latch hole, there must be a latch. Hooks without latch holes can be special ordered from CM if a latch poses a hazard to the user. So just
Correct.
to let you know. Okay, perfect. Thank you, Troy. A couple more questions. What kind of NDT should be performed on a hook? Penetrating liquid or magnetic particle?
Well, they're both non-destructive tests, so you can use either one as long because they're both non-destructive, so you're not going to hurt the material that it's made from. But there's nothing that says that you have to do that. That could be simply your personal procedure, that personal company's procedure on how to do their inspections. And I've run into that, quite a few times. But there's nothing in any of the standards that says you have to do a non-destructive test.
Okay. On a hoist, does the hook need a latch?
Yes, unless the latch presents a hazard to the operator. That is the only time the latch can be removed. But other than that, all hoists, all cranes must have latches.
Okay, thank you. And then this is another follow-up. If the tag is missing upon inspection, can the chain sling be re-tagged for service without knowing the original sling length?
I don't see how, because then you're not going to be able to tell if the sling has actually been elongated or stretched.
Right.
Or is, it could be a combination of wear and some stretching that took place that could actually make the chains longer. So I don't see how that can happen.
Okay.
There may be a way, but I don't see it right now.
Okay, and we have two final questions, and then we will conclude. Is there any rule that states how many times a chain sling can be repaired before removal from service?
Not to my knowledge, no.
No. Okay.
As long as the repairs are kept up, there's no reason why that sling can't last a very long time.
Okay. All right. We use continuous chain loops to choke wire ropes and pull them. Are tags required as they are not actually lifting vertically but pulling horizontally?
If all you're using is chains to pull a load and it does not pick anything up, it is not considered an overhead lifting item. But once you do go into the vertical position, then you must have a tag. It's like grade 70 chain. You can use grade 70 chain horizontally. You can use grade 30 or 43 horizontally for pulling purposes, load securement, but you can't use those to pick things up. And none of those are required to have tags.
Okay. If you can move along, Henry, just to conclude here, we did have a question about the training that we offer specific for rigging, rigging certification. So if you can just flip over to that slide, there you go, and just cover some of the upcoming training and you know, what we offer.
Yeah, we do offer a wide range of different types of trainings. You can see here coming up in July, we do have one in Chicago for overhead crane and hoist inspection certification. That is a 3-day class. We also in June, middle of June, we have a 3-day rigging workshop that is coming up here in New York. And actually, this is the only facility, the only location that we offer this class. And that is simply because of the items that we use here to make the class a little bit more interesting. We do a lot of hands-on here. All right, and then we do have a rigging and crane op that runs at the same time as the 3-day rigging workshop. It's actually part of the 3-day rigging workshop. And as a crane operator, train-the-trainer rigging workshop, the first day we go through the crane operations and talk about how the crane operator's responsibilities as far as checking the hoist out, checking the crane out. And then, of course, he'll get into rigging loads too, because a lot of the industry today, you've got crane operators are actually riggers too, because they're actually picking up the loads and putting them in their machines or putting them on pallets and things like that. And then, of course, the last day, it would be on a Friday. We also offer, and that's completely your choice, if you want to take a test. That is, we administer the test, but the test is electronically given from CIC, which is the Crane Institute certification company located in Florida. They are a third-party company that we basically are prepping you for that test. And what that does is you'll get a certificate not only from us that will allow you to do these things, but you'll also get a wallet card and a document from CIC saying that you are trained and qualified to be say a basic rigger or a advanced rigger. And there's only like 2 or 3 companies in the country that offer that service, and CIC is one of them. And we've partnered with them to do that.
Okay, excellent. I just want to let you know, because I know many of you come every month to our series, but we will be taking a break over the summer. So we're going to be starting back in the fall, maybe September-ish. So we hope you join us then. And in the meantime, we just want to thank everybody for participating today. I know there was a question. I'll sort that out. There was a question someone wanted to see a previous slide where it said that only Hammerlock can be used and no other devices. Henry, could you flip back to that slide on the Hammerlock? That would be great. But in the meantime, please connect with us on social media if you're active on social media. We are on all the channels, just about all the main channels, Twitter, Facebook, LinkedIn, YouTube, Google+. And we also have a blog with a ton of articles, many of which tie into the topics that Henry spoke about. So in the follow-up email, I'll be sure to include a few links to those articles so they might help you understand some of these topics maybe a little more in depth. But anyway, here is the slide that you were looking for, and I hope that helps. Thank you all for coming. We wish you a great soon-to-be summer, and we look forward to connecting with you again in the fall. We'll stay on a few more minutes for additional questions if you have any.